Welcome to this explainer. Today, we're diving into a really insightful technical article by Valerio Barbera, originally presented for the International PHP Conference. We are going to methodically break down how to bridge the gap between theoretical AI concepts and practical PHP implementation using the Neuron AI framework. Our approach here is going to be calm, precise, and completely grounded in the mechanics of building a functional system. So here's our roadmap for constructing the architecture. We'll cover the implementation gap, the core concept of RAG, the mathematics of embeddings, class construction, data loading, and finally, system observability. Let's start with Section 1, the RAG implementation gap. The article establishes that moving beyond a simple chat script is usually the very first wall PHP developers hit when building AI applications. Imagine a PHP developer surrounded by all these disconnected, isolated stages. You have document parsing on one end, generating vector embeddings on another, maintaining storage in a vector database, and then finally attempting prompt orchestration. The text argues that manually gluing these disparate libraries together just results in a brittle, frustrating architecture. And that friction is exactly what the Neuron AI framework was designed to eliminate, by abstracting these moving parts into a unified data pipeline. Moving to Section 2, Retrieval-Augmented Generation. Let's demystify what RAG actually means in practice. The article explains that generative models are incredibly powerful, but they're severely limited by strict training cutoff dates. They simply don't know your proprietary company data. Retrieval-Augmented Generation solves this. Visualize a workflow where you ask a question, an AI agent queries an external knowledge source, that retrieved context flows directly into the large language model, and an informed response returns to you. The retrieval component essentially acts as a research assistant, injecting current, domain-specific information right at response time. Section 3, Embeddings and Semantic Search. This is the mathematical core of the system. The article explains that an embedding transforms text into points within a multidimensional vector space. By converting documents into these mathematical lists of numbers, a system can calculate which document vectors sit closest to your question vector. To visualize this, the article outlines how related animal terms like wolf, dog, and cat cluster tightly together in one area of this multidimensional space, while fruit terms like apple and banana cluster in a completely different area. The proximity is based entirely on meaning. To highlight a personal observation from the source, Valerio Barbera notes his own initial amazement at seeing how meaning-based proximity transforms document retrieval. It represents a fundamental shift in how applications process information. And the article points out a really important distinction here. Traditional keyword search requires exact wording matches or complex Boolean logic. But with semantic search, querying a phrase like connection issues automatically surfaces documents about network problems, authentication failures, or server timeouts. It retrieves highly relevant context without ever requiring the exact phrasing, operating much like a librarian who understands the actual intent behind your request. Section 4, Building the RAG class. Okay, so the crucial point is taking this theory and placing it into a clean, precise PHP code environment. The author recommends starting by installing the core framework and RAG components via Composer. Executing this single command sets the technical foundation for our system. Next, let's look at the custom class orchestration. The text outlines that to orchestrate the application, you create a custom class, let's call it myRAG, which extends the framework's core RAG class. Within this class, you have to configure 3 specific connected components. First, the AI provider, such as Anthropic, which is responsible for generating the final response. Second, the embeddings provider, such as Voyage, which handles converting your text into vectors. And third, the vector store, such as File Vector Store, which persists those vectors and performs the document retrieval. Configuring these 3 providers is exactly how Neuron AI organizes the architecture. Section 5, Loading and Querying Knowledge. Now, just setting up the class components isn't quite enough. The article explains that an initially empty vector store means the agent is going to fail if you ask it about private company data. The source uses this specific question to demonstrate the point. What size is the door handle on our top car model? If you send this prompt to an empty agent, the language model will just fall back on its pre-trained data and politely fail to provide a proprietary answer. But the article details how to fix this using the built-in data loader pipeline. The file data loader automates the preparation of your internal documents in just a few lines of code. It processes files by first extracting text from formats like Markdown, PDF, HTML, and XHTML. It then splits, or chunks, the content appropriately. Next, it passes those documents through the pipeline to generate embeddings, and finally, it persists them into the vector store. This brilliantly replaces brittle manual scripts with an automated, built-in workflow. Once that vector store is populated, the application is ready. By sending a user message through the chat method, the agent now successfully retrieves the proper loaded context. It can confidently answer the door handle question based directly on the proprietary data we just ingested. Section 6, Observability and Next Steps. As we move to the final piece of the architecture, we have to look at how to actually maintain these production-grade implementations. The article argues that developers critically need to inspect what an increasingly complex agent is doing. When an agent runs, it involves multiple step invocations, tool usage, and external memory access. Developers must be able to trace model decisions to understand exactly what specific data the agent is reacting to. The article explains that Neuron AI was designed with built-in observability features to handle this. By simply adding an inspector ingestion key to your environment file, you can monitor the system in real time. On the Inspector dashboard, developers can visualize nested workflow steps, track precise execution timing, monitor memory usage, and verify the agent's internal activities. This level of inspection ensures that your AI applications remain transparent and maintainable. The core message of the source material is that building reliable AI systems no longer requires brittle manual orchestration. By utilizing abstract, built-in pipelines, developers can handle complex integrations and preserve customization. What begins as a theoretical understanding of embeddings and multidimensional spaces can now translate smoothly into a production-ready system. Are you ready to move beyond brittle chat scripts and start engineering truly intelligent, context-aware PHP applications? Thank you for joining this explainer, from RAG theory to a working PHP agent.